All right, everybody, let's talk about erythropoiesis. So, erythro, has to do with the red blood cells. And then poiesis, as we mentioned earlier, has to do with creating. So, we are going to create red blood cells. Before we go any further, let's just remember the importance of red blood cells. And the main reason why we have them is to carry oxygen throughout the body so that we can do cellular respiration. So, we're going to do erythropoiesis to create more red blood cells because we need more oxygen to travel through the body. Where does this happen? This is going to take place in bone marrow, specifically the red bone marrow at the end of our bones. So I'm going to draw a real quick picture over here. So if I have a bone, this is my really poor illustration, right? So if we have a long bone, for example, our red bone marrow, if we remember, is going to be found primarily at the ends of long bones. Our yellow bone marrow in adults is going to be down in the center. So, just reminder of that. So, we're going to see about 2.5 million red blood cells produced and destroyed every second, which is a lot, right? So, we're constantly creating and destroying red blood cells to make sure that we have healthy cells continually flowing through the body. Who does this, right? Where do they come from? So, one of the terms we're going to discuss real quick, just to make sure we're on the same page, hemo has to do with blood, hemo, cyto means cell, blast, the baby cell. So, how do we make red blood cells? It all starts here with the hemocytoblast. These are going to mature, again, because they're baby cells. They're going to mature and eventually turn into these red blood cells. All right, so if I want to create red blood cells, I have to create more hemocytoblasts first. In the middle, right, we're going to see these reticulocytes, which are the middle stage. The middle stage of red blood cells. So I have my hemocytoblasts. They're going to mature into reticulocytes. And then eventually, after a couple days, they're going to mature into red blood cells. So just keep that in mind. These are the three stages, major cell stages of a red blood cell. Normally, these reticulocytes only account for a very, very, very small percentage of red blood cells, about less than 1%. If we do see more than that, right, this is an indicator that we may have an oxygen deficiency, such as bone marrow cancer. And if we have less than that, this is something that is something you might see in anemic people who have kidney diseases, just for examples. Now, with that said, just like what we've discussed before, whenever we're talking about negative feedback loops like this, such as red blood cell levels, I'm just going to give an example with this little graph here, right? Again, this is just like a example of a graph. It doesn't have to be perfect, right? So this is your normal or the set point of how many, in this case, red blood cells are supposed to be. So this is red blood cells. Something happens in the body. I'll do this in blue. Something's going to happen in the body that's going to tell your body we need to make more red blood cells, right? In this case, I want you guys to think about that, right? Why would we want more red blood cells? And in this case, something's going to trigger it. And when that happens, we have more red blood cells. And then eventually something else is going to tell the body, hey, we have enough. Stop making them. And then eventually we're going to come back down to normal. We can also do the opposite of this, which is something happens, your body recognizes we don't have enough red blood cells, so we are going to produce more to bring us back up to normal. Right? So in this case, we have too many, we got to bring them down. In this case, we don't have enough, we got to bring them back up. Right? So this is just a negative feedback loop. So I bring this up because there are a couple of negative feedback loop scenarios that we need to discuss, right? And like I said earlier, what would be a situation where your body would want to create more red blood cells? And an example could be right here. you need more oxygen to your body tissues. Again, red blood cells carry oxygen, so if you need more oxygen, one thing your body will do is create more red blood cells. So that's important. But just like we talked about in that graph, I'm going to draw it again right here real quick, right? We want to have them, but we don't want too many. We don't want too few, right? We want to be in this middle ground. That's the goal. We want to stay at normal, right? And the reason why is because we want to be able to carry enough oxygen, but also not have too many red blood cells because they will clot and you can have a stroke. So we got to watch out for that. You don't want to have clogged arteries. That's not good. So too many red blood cells, they get stuck in the arteries. So let's discuss the two ways that we're going to discuss, at least in this class. Two different ways we can control the red blood cells in your arteries and in your body. Number one, hypoxia. Right? Again, low oxygen. So the first possibility of what's going to happen here, your liver is going to indicate or determine that we don't have enough oxygen, and it's going to tell the body to activate erythropoietin. All right. What the heck is erythropoietin? This is the major hormone responsible. This is the major hormone responsible for telling your bones to create more red blood cells. So if you have more erythropoietin, actually right here, more erythropoietin, that means we are going to create more hemocytoblasts. And if we have more hemocytoblasts, we are going to be able to create more red blood cells. So if we look at this chart, let's say we're here, we're at the bottom of the chart, we create more erythropoietin, therefore more hemocytoblasts, and then therefore more red blood cells. What happens when you have more red blood cells? We have more oxygen. And this is one example of negative feedback that happens in our kidneys. So, that's one example. Very important. So we also learned about erythropoietin. Keep in mind, erythropoietin is also known as EPO because it's a little bit easier to remember instead of saying erythropoietin every time. So this, more erythropoietin equals more red blood cells. And if we have more red blood cells, that means we should have more oxygen. Another example could be something like, again, going back to hypoxia, hemorrhage, so bleeding in the body. You're not breathing well enough. You're not able to get as much oxygen into the body. This can be literally breathing. The process of doing that breathing, oxygen entering the lungs, but also could be internal, right? So you can argue that a person is not able to adequately breathe because of internal factors as well. So not able to fully respire and to get the oxygen out of the lungs and into the bloodstream, or the CO2 out efficiently. High altitude areas typically have low oxygen, so that makes it harder to get oxygen into the body. And then people with anemia, again, we talked about anemia before. So going back to this image here, just like we talked about, kidneys specifically are going to create this erythropoietin, and then therefore more hemocytoblasts, and then therefore more red blood cells. More red blood cells, more oxygen. And now that I've repeated myself multiple times, I think hopefully can better understand what's happening here. If you have any questions, please let me know.